Hello, this is Mr. Precella discussing the graphical method for solving linear programming problems. If you've been watching through the videos, you've already seen the corner point theorem stated. If you have a closed, bounded, feasible region, then both a maximum and a minimum value occur at corner points. So in some of the homework problems you have look sort of like this, where you're given the shaded region and even told the corner points, in which case all you've got to do is just plug the corner points in up here. Since this is a closed bounded region, then you have both a maximum and a minimum value occurring at those corner points. Here's another closed bounded region where you have to plug in the corner points, and since it's closed and bounded, it'll give you both a maximum and a minimum. Now, here's one where I've already done some examples like in other videos, where you have to draw it out yourself, this feasible region, and it'll look like one of these where it's a closed and bounded feasible region. What I want to do is, let's see, I'll start off, I'm going to do this problem number 7. If you've watched through the videos, there's a video where I'm working a problem like number 6 and also like number 8. So I'm going to do number 7 right now. I've already done 6 and 8. Those each have separate little videos. So I'm going to do problem number 7. First, let's see it. Problem 7 says, find the maximum and minimum value of z equal 25x plus 23y subject to these constraints. Well, we're going to have to draw those inequalities out. I'm going to start off graphing 3x plus 2y is greater than or equal to 6. I'm going to draw it as the line 3x plus 2y equals 6. So I'll do that just by finding the intercepts. By that I mean plug a 0 in for x, figure out y, plug a 0 in for y and figure out x. If you plug a 0 in for x, 3 times 0 is 0 plus 2y. I'm thinking of it as equals. Divide both sides by 2 to get y equals 3. So there's one ordered pair. Now plugging a 0 in for y, we just have 3x equals 6. So divide by 3 to get x equals 2. So I'm going to plot those two ordered pairs and connect the dots, and then we've got to decide how we're going to shade. So I'm going to have some graph paper right here. Let's see. Let me draw the x-axis and the y-axis. Okay. So the two ordered pairs are over 0 up 3, over 0 up 3, 1, 2, 3, that's the point 0, 3, right 2 up 0, right 2 up 0, connect the dots. Now, if you, well, we've got a shade on either side of that purple line, but I don't want to shade it real darkly. I'm going to test 0, 0, and if I get a true statement, then I'm going to shade below the purple line. If I get a false statement, I'll shade on the other side. So if I get true, I'm going to shade the side that has 0, 0. 3 times 0, so when I'm testing, I'm plugging in up here. 3 times 0 is 0, plus 2 times 0, 2 times 0 is 0, is greater than or equal to 6. That's false. So I'm not going to shade below the purple line, I'm shading above the purple line. So let's just remember that we're shading above the purple line, but before I actually do anything more, let me go ahead and sketch those other inequalities. There were some other inequalities given to us on problem number 7. Look at those. This one here, 0 less than or equal to x less than or equal to 10. You should read that as x between 0 and 10. It's telling us that our x values are between 0 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all our x values are between 0 and 10. And then this one here says that all the y values are between 0 and 4. So y values between 0 and 4. Excuse me, between 0 and 5. 1, 2, 3, 4, 5. All the y values between 0 and 5. Okay? So we want the region. What's the feasible region? The region that's above the purple line, but also inside this little rectangle. Like way over here, this point would not be in the feasible region. Oh, let me lift this up a little. Okay. Let's see. Do I need to try to refocus? Is this, let me see. Do I see that graph? Going to refocus right there. So all the points that are above the purple line and inside this rectangle, I'm going to darken it. You know, on some of those problems you've got to do something to find those points of intersection. Either use elimination, substitution, or you could use Gauss-Jordan in your calculator. But here you can just sort of look at it and tell the points of intersection for all of them. There's 0, 3, 2, 0, like this point right here. That would be the point right 10 up 0. This point right here would be right 10 up 5. And then we already have the point 0, 5 right there. So there are a lot of points of intersection. 1, 2, 3, 4, 5. I'm going to make one of my little tables right out the corner points. There's 0, 3, 2, 0, 0, 5, 10, 0, and 10, 5. 10, 5 is probably where the maximum is going to occur. And the function that we're trying to maximize and minimize is 25x plus 23. That's a 23y. So we're going to plug in a 0 and a 3. 25 times 0 plus 23 times 3, that's a 69. Now plug in a 2, 0. 25 times 2, 50, plus 23 times 0 is 0. So 50 what about plugging a 0, 5 in? 25 times 0 is 0. 23 times 5. That's going to be 100 plus 15, so 115. 25 times 10 is just 250. 23 times 0 is 0, so just 250. And finally the 10 and 5. Plugging in a 10, it would be 25 times 10, 250, plus 23 times 5. 23 times 5 is 115. So what are we getting here? 365. So this is a closed and bounded region, so there's both a maximum and a minimum. So the biggest number there that we got would be the maximum. So 365 is the maximum. And what's the smallest number we got there? Was it 50? That'll be the minimum. Now, okay, it did happen. Sometimes my math lab, it doesn't happen often, but every now and then, look at this. The reason I chose this one to do is the way mine regenerated, none of these has the right answer. 365 is the maximum, but 50 should have been the minimum, not 69. But the only thing that's, what are we going to do here? Well, the closest, we're going to choose the closest wrong answer, okay? Instead of that 69, it should have been a 50. Do y'all agree with that? When you plug the 2 and 0 in, you get a 50. Now, so for number 70, or number 7, for a lot of times it does like this, but then just the other day my brother did one of these in his, this number 7 in his class, and it had the right answer, okay? So it's sort of, be careful. You get 2 on this multiple choice problem, you get 2 guesses, so generally generally what I've noticed is a lot of time on this problem, the maximum will be right, and it's the minimum that's wrong. So go with that one. It's the closest one. Okay, the actual maximum is 365, minimum 50. The closest answer here would be 365 and 69. And you get 2 guesses with that. And I debated removing it from the assignment, but I like this problem so much because the graph looks so nice. You don't have to do anything to find those corner points other than just look at the graph real closely. Okay? And that's another reason I wanted to do number 7. It's actually, it sets up easier than 6 and 8, but, and again, I have videos of those already, but the downside is sometimes the minimum value answers are a little off on here. Okay? Now, the main thing I'm going to do today is work on these, do some word problems here. So right now, I'm going to start doing an application problem. This is problem 9. A chainsaw, it's the chainsaw and wood chipper problem. A chainsaw requires 7 hours of assembly and a wood chipper 8 hours. A maximum of 112 hours of assembly time is available. The profit is $160 on a chainsaw and $220 on a chipper. How many of each should be assembled? What we want to know is how many chainsaws and how many wood chippers they should be making. So our unknowns, X and Y, will be the number of chainsaws and the number of wood chippers. Now we need to summarize all this information. We're told that the chainsaw requires 7 hours of assembly. So let's have a assembly column. 7 hours of assembly. The wood chipper requires 8 hours of assembly. All they have is 112 hours of assembly time available. So I'm going to draw a line here, and it's not really an equal line. If they have 112 hours of assembly time available, that means that they've got to use, they can't use more than 112 hours. So that would be a less than or equal to 112. Now we have a profit column. The profit on a chainsaw is $160, and on a wood chipper $220. So I think we've summarized all the information. We want to know how many of each should be assembled for maximum profit. So what I want us to do here is just set up the problem. Well, how would we set it up? We'd say maximize. And now, how would we calculate that profit? Since it wants to maximize profit. I'm going to write P for profit equals. The profit is 160 for every chainsaw. So 160x plus 220y. They're making $220 profit for every wood chipper, $160 profit for every chainsaw. Now we need some constraints. So we'll say subject to, and we really have only one constraint here, the assembly constraint, in addition to the non-negativity constraint. So if it's taken 7 hours to assemble each chainsaw, to calculate the amount of assembly time, we'd say 7 times x. It's taken 8 hours to assemble each wood chipper, plus 8y. Now, they only have 112 hours available, so we say less than or equal to 112. Now, we still have those non-negativity constraints. By that I mean, it wouldn't make sense for x to be negative. You can't have a negative number of chainsaws. So x and y are both greater than or equal to 0. And what I want you to do now, instead, if you want to graph this out and go about it by hand, okay, but what I would really like you to do is use a website that I have a video showing, phpsimplex.com. And if you put /en, that'll get you in English language. But that's a really nice website. And the reason I'm mentioning that is it sort of helps you move faster. And I have a video showing that. Okay? So just go to www.phpsimplex.com/en. And again, I have a video where I'm actually demonstrating how to use that website. But I can't do that right here on this paper. But there is another video showing you how to use it. And it's very user-friendly, provided you get it into the English language. Okay? It's really nice. You punch in, you choose which method you're using, Graphical or Simplex. We, at this point, probably haven't discussed Simplex here. You'll use Graphical. So watch the video on how to use this. What I want to do now, what I'm doing today, is just showing you how to set up these word problems. And then you go to this website. It's really nice. You punch in this problem, and it gives you the answer. It'll draw the graph out really nicely for you and so forth. So now let's do another word problem. Okay. Here's the next example we're going to do. Okay. Deluxe coffee is to be mixed with the regular coffee to make at least 49 pounds of a blended coffee. The mixture must contain at least 10 pounds of deluxe. Deluxe coffee costs $5 a pound, regular $4 a pound. How many pounds of each should be used to minimize costs? So we want to know how many pounds of deluxe coffee and how many pounds of regular coffee should be mixed together. Okay? So I'm going to say X is the number of pounds of, what did I talk about first? Deluxe coffee. So I'm letting X be deluxe coffee and Y is the number of pounds of regular coffee. Deluxe coffee is to be mixed with regular coffee to make at least 49 pounds. That's sort of a total of X plus Y. They need at least 49 pounds. Now, let's think about at least. That isn't the same thing as equals. It's not exactly 49. At least 49 would be 49 or more. At least is greater than or equal to 49. Sometimes students get it mixed up. They think less than. But no, at least means greater than. Think about it. At least 49 pounds means 49 or more. The mixture must contain at least 10 pounds of deluxe. So there must be at least 10 pounds of deluxe coffee. Deluxe coffee costs $5 a pound. So here's a cost column. $5 a pound. Regular coffee costs $4 a pound. How many pounds of each should be used to minimize costs? So you want to minimize the cost. So to set it up, minimize the cost is $5 for every pound of deluxe and $4 for every pound of regular. If you want to write C for cost equals, okay, or if you just want to write 5x plus 4y. Now, subject to, what are our constraints here? Well, there's 49 pounds. They need at least 49 pounds of blended coffee. So that would be x plus y. If you add those together, ooh, what happened there? The motion sensor. Somehow, every now and then, the motion sensor will just cut off the lights in this room. X plus y greater than or equal to 49. And then we still have that one other constraint that we need at least 10 pounds of regular coffee. X must be greater than or equal to 10. We have the non-negativity constraints. By the way, when you punch this stuff into phpsimplex.com, you don't punch in the non-negativity constraints. It will always assume those. Okay? So here's how you set it up. To get the actual answer, it's my intention that you go to phpsimplex. If you want to graph it out and do it that way, okay. But sort of wanted you to try doing this using a website to help you with some of these. Okay? So y'all see how I set that one up? That's all I'm doing today now. It's just setting up some word problems for you. Let's try another one. This next one, I always like to make up a little story about why Jacob is eating like this. It's number 11. It takes 8 units of carbohydrates and 4 units of protein to satisfy Jacob's minimum weekly requirements. He's going to eat only 2 food items, meat and cheese. The meat has 2 units of carbohydrates and 2 units of protein. The cheese has 3 units of carbohydrates and 1 unit of protein. The meat costs $3.20 a pound. The cheese costs $4.50 a pound. How many pounds of each are needed to fulfill the minimum requirements at minimum cost? I can't imagine anyone's just going to eat meat and cheese, and they want to do it as cheaply as possible. So maybe Jacob's some sort of political prisoner in a country, and they want to keep him looking healthy, but they don't want to spend a lot of money. They're going to feed him nothing but meat and cheese. Can't imagine someone just voluntarily deciding they're going to eat meat and cheese and nothing else. And they want to do it as cheaply as possible. So, number 11. So we want to know how many pounds of meat and how many pounds of cheese they should have here. Well, let's see. In the description of the problem, they talk about what? Meat and then cheese. So I'm going to let X be the number of pounds of meat, and Y is the number of pounds of cheese. Notice they ask you for cheese first before meat, so you make sure once you get the answer, you plug it in the correct order there. Let's see. It takes 8 units of carbohydrates and 4 units of protein. Carbohydrates, protein. So that 8 and 4, those are totals. It takes 8 units of carbohydrates and 4 units of protein to meet Jacob's minimum weekly requirements. Meat contains 2 units of carbohydrates and 2 units of protein. Cheese contains 3 units of carbohydrates, 1 unit of protein. The meat costs $3.20 a pound. Cheese costs $4.50 per pound. How many pounds of each are needed to fulfill the requirements at minimum cost? So we want to minimize the cost, which would be $3.20 times every pound of meat plus $4.50 times every pound of cheese. Then we got to get the constraints written. Well, this 8 and 4. Jacob needs 8 units of carbohydrates. That's his minimum weekly requirements. If those are his minimum, then that means he needs at least 8. That would be 8 or more. Sometimes students put less than or equal instead of greater than or equal. And if you do that, you're going to mess it up. Okay? If Jacob were trying to eat less than 8 units of carbohydrates as cheaply as possible, he just wouldn't eat anything. It wouldn't make sense for this problem to have a less than here, because if you did, then okay, just let him eat nothing. So we have the carbohydrate constraint and the protein constraint. 2x plus 3y, the amount of carbohydrates, must be greater than or equal to 8. That 8 is his minimum. He could eat more than that, but he's got to eat at least 8 units of carbohydrates. Same thing's true for the protein. 2x plus 1y greater than or equal to 4. We have those non-negativity constraints that I'll write, but you're not going to actually punch those into PHP simplex. It will assume those. Oh my goodness, there is something wrong here with these lights that are blinking. Okay, it's not something's going on with the lights in this ride. Okay, so you go to PHP simplex.com/en, well, www there. And I have a video showing you how to use this website, though it's really user-friendly, so it shouldn't take too much effort to get the hang of it. You're basically, with a pull-down menu, you choose minimize or maximize. You punch in the objective function. Then it asks you how many constraints, that's the less than or equal to statements, you would say 2, and then they walk you through, and you're changing this symbol with pull-down menus. Okay? And then it just gives you the answer. Let's do another one of these. Okay, number 12. This is the insurance problem. Company is considering 2 insurance plans. Company's considering 2 insurance plans with coverage and premiums shown. it needs at least $150,000 fire and theft insurance and at least $2,400,000 liability coverage. How many units should be purchased to minimize the cost of the premium, and what is the minimum premium? So we really want to know how many units of policy A should be bought at $50 a unit, and how many units of policy B should be bought at $40 a unit. I'm going to let X be the number of units of policy A, and Y is the number of units of policy B. We're given some totals. They need at least $150,000 in fire and theft insurance. So at least $150,000 in fire and theft. Now, when it says at least, is that $150,000 or more, or $150,000 or less? Well, at least means more, greater than or equal to $150,000. They need $2,400,000 liability coverage, and that's at least. So that would be greater than or equal to $2 million. They want to get this coverage for as cheaply as possible. If in the process they wind up getting more than $150,000 in coverage, okay. They get more than $2.4 million in liability coverage, okay, as long as it's the cheapest way possible. Now, we want to minimize the cost. So minimize, I'll say C for cost, equals, it's $50 per unit, so 50x plus 40y, subject to, here are constraints. Here we have two constraints, okay, the fire theft constraint and the liability constraint, in addition to the non-negativity constraint. So they're getting $10,000 of protection for every unit of policy A, $15,000 for every unit of policy B. So it would be 10,000x plus 150,000y must be greater than or equal to $150,000. That's the fire theft constraint. Now see why I'm using 10,000 times x? It's 10,000 for every unit of policy A plus 15,000 for every unit of policy B. Doing the same thing to get the liability constraint. 180,000x plus 120,000y greater than or equal to 2,400,000. Now we have the non-negativity constraints, which you don't punch in on PHP Simplex. And when you do that, you will get answers for all of those. Okay? That's a really nice website that I keep mentioning. And if you don't like that website, there's a lot of them. Just do a Google search on linear programming calculator or something like that. But of all the ones I've seen, this is the one I like the best. phpsimplex.com/en. www.phpsimplex.com/en. Again, there's a video showing that. Let's see. Here's our next one we're going to do. Okay, here's our next one. It's problem number 13. Okay. Some nice applications here. An animal feed is to be mixed from soybean meal and oats, and it must contain at least 168 pounds of protein, 27 pounds of fat, and 14 pounds of mineral ash. And it goes through telling you, okay, how much each of those costs and so forth. And they want you to set it up. This one specifically spells it out. Let X be the number of sacks of soybean and Y be the number of sacks of oats. So on this one they're telling you X, the number of sacks of X is soybean, Y is oats. So now I'll start reading through, just sort of setting it up. Okay. An animal feed is to be mixed with soybean meal and oat. It must contain at least 168 pounds of protein. Looks like we're going to have a protein column. Needs at least 168, so that would be greater than or equal to 168. And at least 27 pounds of fat. That's another total. And at least 14 pounds of mineral ash, whatever mineral ash is. Now, each sack of soybean, there's another column, so we're running out of colors, cost column. Sometimes that orange is hard to read. The cost column. Each sack of soybean costs $21. And then look, it tells you, okay, it has 70 pounds of protein, 9 pounds of fat, 7 pounds of mineral ash. Now the same thing for the oats. Each sack of oats costs, oats costs a lot less. Oh, but there's a lot less protein. It contains 21 pounds of protein, 7 pounds of fat, 1 pound of mineral ash. So we want to find the minimum cost, so hopefully you're getting the hang of this. They all sort of set up sort of the same way. You say minimize, and what would the cost function be that we want to minimize? Well, it would be $21 times every sack of soybean and $7 for every sack of oats, subject to we have several constraints. The protein constraint. How are you calculating the amount of protein? Will it be 70 times X plus 21 times Y, and it must be greater than or equal to 168 pounds. Why am I using greater than or equal to? Well, it's this wording. They need at least 168 pounds. That would be 168 pounds or more. Now doing the same thing, the fat constraint would be 9x plus 7y greater than or equal to 27. The mineral ash, 7x plus 1y greater than or equal to 14. And we still have those non-negativity constraints, which all right, but you don't punch those into PHP simplex. And then it gives you the minimum cost. When you actually plug it in with these numbers, you get something like $51.28. And then down here, when you're typing in the answers for X and Y, those are going to turn out to be fractions. That's why it then starts asking you this other question. Are the answers reasonable? How could they be interpreted? Okay? And well, the answer there would be this one here, A. The answers are not reasonable because it doesn't make sense to buy a fraction of a sack. The number of sacks of soybean and oat should be rounded to the nearest whole sack. But when you do these, you'll get fractions here, or at least that's what happens when I do my number 13. Okay, when I punch this in and get an answer, I get something like $51.28 for the minimum cost. And X turns out to be the fraction 87 over 43, and Y turns out to be 54 over 43. Can you imagine going into a feed store, telling them you want to buy 87 over 43 pounds of soybean and 54 over 43 sacks of oats? I said pounds, I meant sacks. Okay, we're looking at sacks, not pounds. Okay. Okay, we have time to do one more of these. This is the Kevin is an auto mechanic problem. Kevin is an auto mechanic. He spends 2 hours when he replaces the shocks on a car, and also 2 hours when he replaces the brakes. He works no more than 54 hours a week. He routinely completes at least 4 shocks replacements and at least 6 brake replacements. He charges $400 for shocks, $300 for brakes. How many of each type of jobs should he be doing to maximize his income? So 2 unknowns. X is the number of shock replacements. Y is the number of brake replacements. Let's see, hours. He spends 2 hours on shocks and 2 hours on brakes. Well, it probably would have been a better example if those numbers had been different, but they weren't. He works no more than 54 hours a week. Oh, he works a lot. Well, no more than 54. Let's think. Does that mean 54 and bigger or 54 and less? Well, less than or equal. No more than 54 means less than or equal to 54. Okay. Hey. He routinely completes at least 4 shock jobs. So that would be greater than or equal to 4 shock jobs. He routinely completes at least 4 shock replacements and 6 brake replacements each week. Notice there's not a total there. We're just told that the number of shock replacements is greater than or equal to 4. The number of brake replacements is greater than or equal to 6. If he charges $400 for labor, charges $400 for labor replacing shocks and $300 for labor replacing brakes, how many jobs of each type should he complete to maximize his income? Well, we're going to start off. Maximize whatever letter you want, or not a letter. If you just want to say 400x plus 300y, he's making $400 for every shock replacement, $300 for every brake replacement. He only works 54 hours or less. So our constraints would be 2x plus 2y less than or equal to 54. And then we also have the x, he normally does at least 4 shocks. So x is greater than or equal to 4. He normally does at least 6 brake replacements. Y does say less than or equal to 4. Man, x is greater than or equal to 4. Y is greater than or equal to 6. Punch this into www.phpsimplex.com/en. You'll notice I didn't write the non-negativity constraints here. Well, first you don't punch those into PHP Simplex. It assumes those, but they're already taken care of. If x is greater than or equal to 4, it's sure greater than or equal to 0. Same thing for y. Okay? So, any questions there? And all it wants to know is how many shock jobs and how many brake jobs. If I'm remembering correctly, turns out he should be doing 21 shocks and 6 brakes. That'll maximize his income. It doesn't ask for what is his monthly income. Once again, once you get the problem set up, phpsimplex.com/en. It's a nice little, ooh. Can y'all see that? That orange looks invisible to me. But I have a whole video where I'm showing you how to punch in one of these problems in there. And there's a lot of websites you can look around and find. But this one that seems to be one that doesn't have a whole lot of ads. It's a free website. So, oh, it sounds like someone had a wreck. You can hear the sirens outside this room. But hopefully that does it. I hope you enjoyed working on this linear programming stuff. We're going to see another way. The natural question is, well, what if there's more than 2 unknowns? Suppose you did shocks, brakes, and tune-ups or something. Suppose that boy isn't just eating meat and cheese. Suppose he's eating meat, cheese, and potatoes. If there's more than just 2 unknowns, x and y, we'll be using something called the simplex method and still using PHP Simplex. But if you get the hang of setting up these word problems now, we're going to be doing those again on the next assignment also. For those of you listening to this that are enrolled in my online class, on that online class, your second quiz is nothing more than this linear programming stuff. Graphical and PHP Simplex. Excuse me, and something called Simplex method. So I'm out of time now. Thanks for listening, and I hope you're enjoying working these. These are some really nice applications. So thank you. Bye-bye.